You may want to create your own patterning cells, and in fact they are created in exactly the same way as for regular cells. There are some points though that you should be aware of. First, since pattern cells are usually designed to repeat themselves seamlessly, it's important that one full cycle of the pattern in the horizontal and vertical directions is contained in the cell. Now that sounds quite easy, but in fact it can be quite tricky, as you'll see a little later on. Secondly, the elements in the cell define the extents of the actual pattern itself. So if you wanted a cell which had deliberate white space around the inserted pattern, when the spacing is set to 0, you must place point elements to expand the extent of the cell. Now, point elements will be discussed later on in this course, so don't worry about them too much at the moment. You include the point elements in the selection set used to create the cell, but the point elements will not be visible when the area is patterned. Thirdly, you cannot nest area pattern cells, meaning that you can't insert a cell inside the pattern cell. Fourthly, a cell can contain any type of element, including text. And fifthly, if you are creating metric cells from the existing English cells, first place an instance of the English cell in your metric unit design with the true scale option on. This way MicroStation will adjust its English scale to match the metric units. Make any scale and unit adjustments you want to the cell, and then drop the status of the cell. You can now go through the standard cell creation process to create a new metric cell. Let's take a look at a specific cell to see how it's actually constructed. I'm going to go to Element and Cells, and I want to look at a particular cell, in this case, grass. There we are. And look at the display on the right side here. Now, the grass symbol are these 3 lines here, and that's the pattern that will be placed in the area to be patterned. But note that we have more elements in the 2 bottom corners. If you look carefully, however, you'll see that this line in the bottom left corner is the same as that line on the grass symbol, and these 2 lines in the right corner are the same as these 2 lines in the grass symbol. So what does this mean? So let's go and open up this actual cell and see what's actually in it. So we need to open this up as a drawing, which means we have to find the actual Arch PA cell file itself. Now, we are seeing a truncated path here, of course. So to see the full path, we can File, Attach File. We see our whole list of cell libraries, but we see the path up here. So I'm going to open up this Arch PA cell library. So I don't need this anymore, and I don't need this anymore, but I do need to open a file. So I'm going to Open. And I am going to go to my C drive. The path is Program Data, Bentley, MicroStation, Workspace, System, Cells, an endless path. And we need the Arch PA cell. Now this is the actual cell library file. Click on that. Opens up my cell file. Now, I've been playing with this and I'm looking at a concrete pattern here, but I want that grass. If you click on the Models pull-down menu, we'll see an awful lot of models. Now, each of these models is one cell pattern. So we actually have to open a model to see a specific cell pattern. We want grass. Here's grass. Double-click that. Grass opens up. Let me zoom out a little bit. Now look carefully at this. It might be difficult to see on your screen in the video. You can clearly see the same elements that we saw in the display of the cell. Here's our actual cell pattern that will be placed. And here are the 2 extra sets of elements. But look very carefully here. You should see a small dot. If I select that dot, it will highlight. And let's see what it is. Element selection, it says it's a line. But the interesting thing here is that if you look at the Geometries tab, you'll see that the start and end locations of this line are exactly the same. So this is a line with no dimensions, which is what a point is. We'll be looking at points in a later video. For the moment, just accept the fact that there is a point at this location here. What this means is that the physical size of this cell is actually from here, this corner, to the point. And it's the point that defines the upper end of this cell. So technically, this is white space in this area here. Now, the whole point of this is, if I use this as just elements, and if I select these elements, including the point, and I copy them, copy, and I start from this point here. Now, in a cell file like this, you'll find that the regular snaps don't work. No matter, we can guess quite easily. There's my start point. There's my end point. Very carefully there. You see the pattern starting to take place. If I select the same thing again, do another copy, this time copy from this location to the point, you see the effects of copying the elements. I'm starting to see the cell pattern display. So that's how it works. If you're designing a pattern cell yourself, you have to think along these lines. What happens when you copy your elements from corner to corner of the extent of the cell? That's what matters. So if you have the time, it's quite interesting to try and design and create a pattern cell on your own. And in doing so, you'll certainly understand the mechanics of patterning cells and their placement. Now, while you're here, take a look at other particular patterns and see how they look and why they actually work as an actual pattern placement.